And since I just received an email saying that you have to be at school on Friday, no one will be absent, so I'm very excited. All right, so let's get started. About rational functions. All right? The goal of the first half of class is to take a rational function that's given to us and write down as much as we can find out about that function. Ultimately, we're going to use that tomorrow and the next day to graph it. So let's start with this one right here. If you look at slide number 4, if you look at your 4th slide, you'll be looking at the characteristics that I want to find. All right, it says x-intercepts, y-intercept, the asymptotes, and any holes. All right, let's start with the x-intercepts. Do you guys see the numerator? What's in the numerator? And? Excellent. Let's figure out what makes those 0. Not 2. Negative 2. Oh, that's not a 2. And 3. All right, so what I want you to do is I want you to go to slide number 4, which is right here. And where it says x-intercepts, you're going to write negative 2, 0, and 3, 0. Questions on how to find the x-intercepts? How do you find the x-intercepts, Gilberto?
No, you find the what makes it 0.
What makes what 0? What makes the... close. What makes the... Not the denominator, the numerator. Oh, my fault. I'm sorry. Yes, the numerator, Pablo. My bad. The numerator. What makes the numerator 0? Questions on x-intercepts? Let's go. Yes, question. Yes, the numerator. The numerator. What makes the numerator 0? Yes, of course. Let's find the y-intercept. For the y-intercept, you're going to plug in 0 for x. You're going to plug in 0 for x. So we have 0 plus 2 times 0 minus 3 over 0 plus 1 squared times 0 minus 2. For the y-intercept. All right, remember your middle school days. The easiest way to find the y-intercept is to make x 0. Always. All right, so let's do some math here. 0 plus 2. 0 minus 3. Multiply. Thank you. 0 plus 1. Square it. 0 minus 2. Multiply. So we get 3. So when I go to my slide where I'm writing down my characteristics, all my info, I'm going to write 0, 3. That's it for the y-intercept. So how do you find the y-intercept, Jimena? How do you find the y-intercept? Perfect. Plug in 0 for x. Very good, Jimena. Questions on the y-intercept? Lily, yes, question? Your face said question. Say it again. Did I not do all of them? You talking about all the x's? Yeah, I made all the x's 0. Boom, 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 boom. 4 of them.
Okay, for the x-intercept, how come you only chose
only the numerators, right? Because if I make the numerator 0, guys, what is 0 over a number? 0. No, 0 over a number is 0. 0 over a number is 0. 0 over a number is 0. All right? If I make my numerator 0, that'll give me what makes the function 0. That's an x-intercept. All right? Okay.
So we're looking for x, the y is 0, but we're looking for y, the x is 0?
Actually, yes, that's right. X-intercept, you make the y 0. So ultimately, you're writing this for the x-intercepts. And in order to make this whole thing become 0, we need the fraction to become 0. So I want to see the 0 in the numerator. Because in fractions, if your 0 is on top, then it's 0. If your 0 is on the bottom, it's undefined, which leads us to the next thing, asymptotes. Really? A groan for asymptotes? Oh, okay. The vertical asymptotes, you want to set the denominator factors equal to 0. Because whenever we have a denominator that becomes 0, we get undefined. All right, so let's look at the denominator. What's in the bottom? X plus 1 squared and x minus 2. So let's set those equal to 0. This is for our vertical.
So we do the denominator.
I already forgot. Is this it? X minus 2?
So
Cool.
set denominator to 0.
Absolutely. That's for the vertical asymptotes. Denominator equal to 0. So what makes x plus 1 squared equal 0?
1. Then plus or minus.
Ooh, interesting. The square root of 0. The square root of 0, if you do plus or minus the square root of 0, it's just going to be 0. 0 is neutral. It's just -1. Students always overthink it. It's -1. The square really doesn't matter. What about this one over here? All right, so when you go to your vertical asymptotes, you're going to write x equals -1 and x equals 2. Yes, Pablo? Are you going to the next one? All right, now the horizontal, I think the horizontal asymptote is the most challenging thing to find. All right, because it requires you to understand this table here. It requires you to know these 3 things. Some of you are remembering this from your days in pre-calculus. All right, you probably did this. So it's all about the degree of your numerator and the degree of your denominator. The degree is your highest exponent. So let's see, what is the degree of our numerator?
2, 3.
I heard 2 to 3. Degree is the highest exponent.
1.
So I see 1, right? People say 1 because you have x to the first power. But this is another x to the first power. And if you multiply x times x, you get what? X squared. So the degree of the numerator is 2. What about the degree of the denominator?
2.
This is x squared times x, which is x cubed. So the degree is 3.
This is for the horizontal?
Yes, we're doing this for the horizontal asymptote. We're finding the degree of our numerator and denominator. Yes, so some students say, oh, count how many x's, but be careful, because if you have here is that square, it really counts twice. So there's 2 of them times another one gives you a 3rd. Now we need to go back to the table. Which scenario is happening here? Do we have the degree of the numerator is less than the degree of the denominator?
Yes.
Oh, yes, we do. The degree of the numerator,
0.
the degree of the numerator is less than the degree of the denominator. So our horizontal asymptote is y equals 0. Now, does anyone remember how to find holes?
No.
Say it again, Heidi. Y is a y equals 0. If you go to the very first slide, it says the horizontal asymptote of a rational function can be determined by looking at the degrees of the numerator and denominator. We found that the numerator had a degree of 2. Denominator, degree of 3. So if you look at this and try to match it up with one of these 3, you'll see the only one that's true is the first one. The degree of the numerator is less than the degree of the denominator, because 2 is less than 3. So then we write y equals 0 for our horizontal asymptote. So if you look and see what happens when the degree of the numerator is greater by 1, you have no horizontal asymptote. We have what we call a slant asymptote, which we'll be talking about later this week. And then finally, when they're the same, which will happen today, Heidi, you take a ratio of the leading coefficients. The leading coefficients are the numbers in front. What are the numbers in the front here? 1. So if there's no number, it's 1. Well, you'll see later on. There will be numbers. Okay, so how do we find holes? You tell me. Ah, well done, right? Go see the movie. Nobody remembers how to find holes? Not solve holes. How to find holes. The way to find holes in rational functions is to ask yourself, do I have any common factors? Do I have any common factors that I can cross out? No. If you did, you would cross them out and just work with what's remaining, and you have a hole at that factor, whatever makes it 0. All right? I think it'll happen tomorrow or the next one. So, like, if you had x squared minus 9 over x minus 3. Let's say this is your function. You can factor the numerator to be x minus 3 times x plus 3. So these would cross out. You'd be left with just x plus 3. So when you graph x plus 3, it's just a line like this. But do you see how we have x minus 3 was crossed out? What makes that 0? What makes x minus 3 0? Positive 3. What's 3 plus 3? 6. So when you plug in 3, you get 6. That means you'd have to have a hole at 3, 6. So you have a hole in your function at 3, 6. Because that is what would make this 0, right? 3 minus 3 is 0. You'd have undefined. So basically, when you graph this, you're saying, hey, this wasn't the original function, Pablo. It came from this, and I have to account for this, so that's why I have a hole there. Because I crossed out the common factor. I plugged in 3 and got 6. 3 plus 3 is 6. None of the problems today have this. But if you take college algebra next year, oh yeah. Yes.